The universe might look like a vast empty ocean with only a few islands of galaxies. However, this is not quite true. Only a small fraction of all the atoms are inside galaxies, while the rest seems to float in the intergalactic medium, like the roots of a giant tree. Gas spreads out from each galaxy, and gravity funnels fresh material into this dense cosmic forest. In the intergalactic medium, we find the basic building blocks of creation: hydrogen and helium, woven into sheets and filaments that eventually form stars. But if we take a closer look, we'll discover who really holds the reins. Quasars, the most powerful objects in existence. They are incredibly tiny compared to galaxies, residing at the centers of some galaxies, yet they shine with the power of 1 trillion stars. They shoot out massive jets of matter, completely reshaping the universe around them. They are so powerful that they can even affect and change entire galaxies. Astronomers in the 1950s noticed strange and loud radio waves coming from various spots in the sky. They called them quasi-stellar radio sources, or quasars, because they looked like stars, but emitted radio waves instead of visible light. Quasars were incredibly mysterious. Some blinked, and others produced high-energy X-rays along with radio waves. They also moved at incredible speeds, as much as over 30% of the speed of light. The explanation was that they must have been extremely distant, with the universe's expansion making them appear so fast. But these vast distances meant that quasars couldn't simply be stars. They had to be the active centers of galaxies billions of light years away. What's even more astonishing is that they appeared thousands of times brighter than our entire Milky Way. These were truly cosmic monsters, radiating energy in ways previously unimaginable. As we continued to explore the sky, we found over 1 million quasars, and they all seemed to be very far away. Remember, looking far into space means looking far back in time because it takes a long time for their light to reach us. Quasars were particularly abundant in the early universe, around 10 billion years ago, when galaxies and the universe itself were still quite young and provide valuable clues about the early history of the universe. So, let's take a journey back in time, just 3 billion years after the Big Bang, to see what was happening back then. The astounding might of quasars. How can a young baby galaxy shine so brilliantly and be so turbulent? All that light and radiation can't possibly come from stars alone, as there aren't nearly enough of them. Moreover, galaxies tend to grow over time by merging with other galaxies. So, starlight from smaller galaxies shouldn't be much brighter than any modern galaxy. There's only one way to generate the immense energy that quasars emit: by feeding supermassive black holes. We still don't know precisely how these black holes formed, but it appears that almost every galaxy has one at its center. And if you want more videos about these topics, please subscribe now in the channel. But how can black holes, which are known for trapping everything that crosses their event horizon, be the brightest objects in the universe? The light of a quasar doesn't come from inside the black hole itself. Instead, it emanates from the space around it, forming a massive swirling disk of gas called an accretion disk. Quasars use the same fuel as stars to shine: matter. However, black holes are exceptionally efficient at converting matter into energy, surpassing even the most powerful nuclear reactions in stars. This energy release comes from gravity, not from nuclear reactions. As matter falls into a black hole, it accelerates to nearly the speed of light before crossing the event horizon, carrying an enormous amount of kinetic energy. Once inside the black hole, it takes that energy with it. We can only observe this energy release if matter is deposited in a specific manner. When a lot of matter spirals rapidly toward the event horizon, it forms a disk, and collisions between particles generate tremendous heat, raising temperatures to hundreds of thousands of degrees. In a space not much larger than our solar system, a galaxy's core can release energy many times greater than that produced by all its stars combined. In essence, a quasar is a supermassive black hole having a feast, consuming an astonishing amount of matter. Typical quasars devour anywhere from 1 to 100 times the mass of Earth in gas every minute. 10 billion years ago, when the universe was only a third of its current size, the intergalactic medium was much denser, meaning the filaments of gas around quasars could provide them with an abundant feast, causing them to emit staggering amounts of light and radiation. The brightest quasars generate powerful jets that twist the magnetic field of the surrounding matter into a narrow cone, similar to a particle accelerator. They launch massive beams of matter, plowing through the circumgalactic medium and forming plumes that can stretch hundreds of thousands of light years in size. This scale is almost beyond imagination, a tiny spot in a galaxy shaping vast regions of the universe, spanning hundreds of thousands of light years. However, quasars can't sustain their feasting for long, perhaps only a few million years, as their relentless appetite ultimately leads to the demise of their host galaxy. How quasars transform galaxies? Well, maybe killing is a bit of a strong word. After a quasar shuts down, a galaxy doesn't vanish, but it's forever changed. Quasars, among the hottest and brightest things in the universe, alter their galaxies by overheating them and halting star formation. Hot gas can't give birth to stars. This may sound strange since stars are formed from gas that collapses inward and heats up. However, when gas is already hot, its atoms move quickly. When they collide, they push against each other with such force that it resists gravity's pull. So in hot gas, it's tough for stars to form. The ideal gas for creating stars is already cold and doesn't resist collapsing into a star when the time comes. Additionally, quasars expel gas from their galaxies. This not only starves the quasar, but also deprives the galaxy of the materials needed for new stars. As sad as it may sound, this could be a good thing for life. The alternative scenario is much more perilous: too many stars. The birth of new stars is often followed by massive stars exploding in supernovae, which could sterilize planets. But it's not all straightforward. Similar to the intricate balance of our planet's biosphere, every part of a galaxy depends on and influences every other part of the galactic environment. While hot things like quasars and supernovae tend to push gas out of the galaxy, shock waves and quasar jets can also compress gas, leading to the creation of new stars, at least for a brief period. Gas that leaves the galaxy can mix with returning gas and recycle back into the galaxy. In general, we can say that without some moderation, we wouldn't exist as we do today. Now, let's consider a final question. Did the Milky Way ever have a quasar phase in its past? It's not entirely clear if every galaxy experiences a quasar phase, but studying distant quasars might offer insights into the Milky Way's history. Unfortunately, galaxies aren't great at preserving their own history. It's like trying to find traces of history in shifting sands at the beach. There's a possibility that the Milky Way once hosted a quasar, which might have enabled our supermassive black hole, Sagittarius A*, to grow to a size 4 million times that of the Sun. However, we lack knowledge about its ancient history. Even though Sagittarius A* is currently dormant, it could potentially become a quasar in the future. In a few billion years, the Milky Way will merge with Andromeda, and we've observed over 100 double quasars in galaxies colliding. During these events, fresh gas is provided to the central black holes, but this won't last indefinitely. When galaxies merge, so do their supermassive black holes, sinking into the heart of their new galaxy and causing chaos by stirring up dust and stars in every direction. Eventually, none of us will be around to witness this. In fact, we can't be sure if humanity will even endure long enough to reach those distant times. However, if it does, the smartest choice would be to relocate to another galaxy, assuming it hasn't happened already. There, we can start again, creating a better Earth on a superior planet in a more promising galaxy. And about the collide between Milky Way and Andromeda, we can't say for certain if this will happen, but it would undoubtedly be a breathtaking spectacle. Perhaps beings in the distant future will witness it and be awestruck by what they see.